Hi guys, welcome back. We are going to hop into scientific notation for chapter 2. So scientific notation is very important, especially when you're talking about science classes, but in math class too. So we're going to use those same exponent rules that we learned in chapter 1 later on in this chapter, okay? But scientific notation helps us to write very large or very small numbers. So like 300 million we can write as 3 times 10 to the 8th. Because what happens is we have 1, 2, 3, 4, 5, 6, 7, 8 zeros. So I could write this as 3 times 10 times 10 times 10 with 8 tens. 1, 2, 3, 4, 5, 6, 7, 8. And if we multiply that on the calculator, we would get 300 million. So instead of having to write this long number, which might not seem very long to some of you, but maybe we're talking like 20 times this, right? As numbers get larger and larger and larger, or very, very tiny, so even like 0.0000, and we write a lot of zeros. 3, that was a terrible 3. Those things change. So it's very helpful for us to be able to shorthand it, and we call that scientific notation. So a big thing when we're writing scientific notation, the number in front, called the coefficient, must be between 1 and 9. It can't be 0, it can't be 10, it can't be 12, okay? So the first part of this is just to decide if it's scientific notation. So basically, scientific notation is some number times 10 to some exponent, okay? So this number here has to be between 1 and 9. So a horse chestnut has a diameter of 2 times 10 to the 0. So we're just deciding if this is scientific notation. So our coefficient is between 1 and 9, which is 2, and that's great. And we have 10 to some number. So yes, this is in scientific notation. Neptune is about 4.488 times 10 to the 9th kilometers from the sun. So again, the decimal part, okay, so the 4 is between 1 and 9, so that's good. We have 10 to some number. Okay, so this would in fact be, yes, it is scientific notation. The approximate wavelength of infrared light is 0.01 times 10 to the negative 5. Because this number is 0, this is not scientific notation, and we'll just shorten that with SN. Okay, so we can make that number scientific notation, but as of right now, it is not. Even though we have 10 to the negative 5, it's not in scientific notation. Okay, so go ahead and try this one on your own and see if it's yes, it is in scientific notation, or no, it's not in scientific notation. So this 10 is not between 1 and 9, so this is not in proper scientific notation. So this would not be SN, not scientific notation. Okay, so the next part is we're going to practice writing a number in scientific notation. So these numbers, 427.7, we probably wouldn't write in scientific notation normally, but we're going to practice with some smaller numbers. So we want to move the decimal place until we get the number in front of the decimal to be between 1 and 9. So right now 427 is not between 1 and 9, so I'm going to move the decimal 1 over here. But that's 42.7, that's not between 1 and 9, so I'm going to move it one more time. 4.277 would in fact be between 1 and 9. So 4.277. Okay. Now, I can't just say it's 4.277 now, so it's going to be times 10 to the something. Now, because I moved it 2 to the left, I moved it 2 spots, I'm going to have a 2 here, and it's going to be a positive 2. Because basically, if I did 4.277, times 10, times another 10, I'm going to get it to be bigger, right? Because we know 10 squared is really 10 times 10. Okay? So if that helps you to kind of think about it that way, you can think of it in that sense of, is it going to be positive or negative? Because that's what most students mess up on. So why don't you go ahead and try this next one. We're going to try letter C, even though that's technically not next. Okay, so go ahead and try that one. So again, we're going to move this one spot over, that gives me 85, so that's not helpful. Move it one more over, that gives me 8.5, so that's awesome. And because we moved it over 2 spots, that's going to be 10 to the second power. So if we're making a bigger number smaller, we have a positive exponent. Okay, so this would be something good to have written down in our notes. Okay, let's try it a slightly different way. So now this time I have 0.007. So again, I want to move the decimal so I get a number between 1 and 9. If I move it this way, I'm just going to keep getting zeros, right? So that's not helpful. But I can move it backwards. So moving it 1, that still gives me 0. Moving it back 2 still gives me 0. I'm going to move it back 3 whole spots. And that now gives me 7. Times 10. Now we moved it 3 spots. But if I did 7 times 10, that would be 70 times another 10 would be 700 times another 10 would be 7,000. So that doesn't make sense. I can't have a positive 3. But I could have a negative 3. Because as we know, 10 to the negative 3, 10 to the negative 3 is really 1 over 10 to the third. So it's like dividing by 10 3 times. So if I do 7 divided by 10, that's 0.7, times another 10 would be 0.07, divided by another 10 would be 0.007. So when we make a small number bigger, the exponent is negative. Okay, so again, this is something good to have in your notes. Give you a second to write that. Pause if you need to. And go ahead and try this one, please. So again, we want to move the decimal until we get a positive number between 1 and 9. It doesn't have to be positive, it could be negative. And move it back. So I had to move that one back 2 to get 6 in front of the decimal, so it would be 6.0, or you could just write 6. Times 10, we moved it 2 places, but because we made a small number bigger, we're going to go ahead and make that a negative 2. Okay. All right. We can also go backwards. So I'll give you something in scientific notation, and I want you to write it as a real number. So when we have 7.1 times 10 to the third, think of it again like 7.1 times 10 times 10 times 10. So the number is going to get bigger, right? Because we're multiplying by more numbers. So 7.1, I'm going to move it 1, 2, 3 decimal places, and I can put zeros in place. And notice I moved it back, so I got a larger number. Okay, so if we have a positive exponent, the number gets bigger. And again, you should pause the video and go ahead and write that down. All right, last one for today. So I want you to go ahead and try this one. We might actually do one more to make sure we get a negative. Again, I have a positive, so I'm multiplying by 10, multiplying by 10, multiplying by 10. So we're going to go ahead and move this 3 decimal places and tack a 0. So I get 8,120. Now let's say we take the same number, 8.12 times 10 to the negative 3. Okay. So that's like dividing by 10, dividing by 10, dividing by 10. So my number is going to get smaller. So 1, 2, 3 this direction. So I get 0.00812. So a negative exponent means a smaller number. I hope this video finds you well, and we'll talk to you later. Bye.